Hello and welcome to the Mason Storm DIY audio channel. In this video series we are looking at making some hi-fi speakers. In this video we will be doing the preamble to construction. In our last video we designed the crossover for the system we will be making, and I just wanted to point out that this doesn't factor in the enclosure. We use the other program for that. So the base on what we make should sound actually a lot better in this area than what it looks like on our current given graph. Okay, we'll start this process off with firing up WinISD, so we can just kind of close out of that, minimize that, WinISD, here we go. Create new project, and our driver is a Peerless. Find that on here, Peerless, there we go. One driver, and we'll do a vented. And I would like the super boom box. Let's do this super boom box. Super boom box. Okay. So one of my goals is to only use one sheet of plywood. I'm gonna see about getting some birch 3/4 inch plywood to make this out of. And I want to use one because that's half the cost of two. Also, if I just made it so that it, just used the slight amount of a second sheet, that would kind of be incredibly wasteful. So we'll just make the box a little bit smaller than it is here. 2.924, let's try 2.5. Now the next step, we need two different things. One is the enclosure volume, and that will give us the dimensions for how big to make each piece to assemble to create it. And then we need another thing, what's known as a Cutlist, and that's a program that will tell you how to lay out your cuts to get the maximum usage out of a piece of wood. So we'll go back to that calculator we had from before, the DIY audio and video website one, and we can just plug numbers in here till we kind of get what we want. I'm thinking 2.5 cubic feet, so we'll make it a tower. So it's at 35 inches tall, except for that's width. Height 35. It is like a 10-inch driver, so it's probably got to at least be 12 inches wide. 3/4 inch. 13 inches. 15 inches. 14 inches. Well, that's pretty close. If you just do a Google search for Cutlist, this one just kind of showed up at the top, so I'll use it. I've had good luck with this one. So stock 48.96, 4 feet by 8 feet. We got one of those, and let's go on here. The reason why I'm aiming for a little bit bigger is that, well, there's going to be the port displacement and the driver displacement. But I just want to see if this can even be made. So front 12.5 by 35. 12.5, 35, 2. I guess those are the same, so let's do 4, 12.5 by 33.5. Four, 12.5, 12.5. Top, bottom, top, bottom. Okay, calculate. So one of the things with making speaker boxes is you kind of want to have all the sides different. You don't want to have that's what's known as standing waves, which if you made up your speaker box a cube, the distance from the driver from each one of the sides is the same for every side, so you would have actually a point of resonance. So one of the ways you can get around that is have your depth different than your width, and your height different than your depth or your width. And generally just following that helps with a lot of it. Looks like that actually pulled that out. Okay, 4, 8, 12. Looks like that'll work. And the other thing that you can do with this is you can just kind of try different values and see how small you can get the space that isn't used. And it's really handy too, because you just print this off and it actually tells you the order to do your cuts in. Although I don't usually follow that, I just print it off and then kind of cut it the way I want to cut it. But that visual definitely does help, but don't have a computer in the garage that I could animate that with, but I do have a printer, and if I print it out, that usually works out pretty good. The other thing you can do to avoid standing waves is, let's say we have our speakers here. Let's just pretend that's the front. And you get your tweeter, your mid-range, and your woofer. What you can do is, instead of having them like dead center, move them to the left or the right 1/4 of an inch. That way your distance from the left to the right is different. So that's one way to make it so that you don't have any sides that are the same distance from the drivers. So that would get rid of all your standing wave potential. It's probably worth trying other sizes just to kind of see what can happen. But let's just say instead of 12.5 it was 13 there, and this was 15. See if we can get something that's 3 cubic feet. 1335. 1335. 13.5, 33.5. And 13 by 13.5. I did just open up a second tab with the same calculator. See if that's doable. Looks like it is. Probably. Yeah. Now if we're talking getting the most speaker for your, or speaker box for your money, that's probably going to be it. The goal should be to have the tweeter at ear level, so when you're making your own, when you're sitting on the couch that you'll be listening to your stuff with, get somebody to measure how high your ear is while sitting, like from the ground, and then try to go up it that way. Because I guess 35 inches, that is actually a little bit on the low side as far as like height goes. As some towers are like 40 inches, but other ones are in that area. So if it is a little bit too short, I mean, you can probably put feet on it, get it up another inch or two, but any more than that, you're probably better off making it taller, which would definitely affect your most optimum cut, but it's always a trade-off. So we should see if we can get our estimated displacements of our port tube and our driver at least somewhat figured out. So here we have the data sheet of our woofer, and I believe that's 119.8 millimeters. The DIY audio video website does have a calculator for driver displacement. So the mounting depth, oh, well, I guess we'll have to do some conversion. 9.2 inches, 4.7, 4.7, cone diameter. I guess we can just use this 225, 226, 8.9, 8.9, 8.9. If you throw in all the magnets and everything else, it gets you closer. This is just kind of a, I believe it's like a cone volume calculator, and it's, you know, probably accurate enough. But some drivers actually do list the actual displacement, but this one doesn't. And as far as speakers goes, it's pretty standard looking, so it's not really an outlier, so our calculator should be pretty good, because it does have our diameter of magnet there. And magnet height. Or does it have the magnet height? Not really. Yeah, let's leave that as is. What do we get? 0.04. Okay. So let's just kind of round that up to 0.06-ish. And include the mid-range in there as well. Actually, might as well just say it's, if we make the mid-range into its own little enclosure, it'll probably be a 0.1. So let's just say we got a 0.1. Driver displacement 2.91. Okay, so box 2.91. Yeah, 34 ohms. Let's do 33. Should be nice and boomy. Well, not really all that boomy, but more emphasized, I guess. Okay, so we go to our vent. We gotta kind of decide on what our vent diameter is. You can get a lot more air flow with more than one vent or a larger vent diameter. That will also change your port resonance and whatnot as well. I believe in an older version of WinISD they actually had, actually I don't know if it still has it, so actually had all these other air velocity and things. And what can happen is that if your port's too small, you can kind of get all this like noise just because it's, well, it's too small, so you get noise, but it can kind of be a bit problematic. So the way to get around that is you make it bigger, and I believe there's some way where it calculates the amount of power that you put into a driver, in which case it starts to make noise. I don't remember what the name of that calculation was, but this is only a like 100-watt driver, so it shouldn't be as big of a deal. That's usually more of a big deal when actually designing subwoofers. In which case, when you're designing subwoofers, you usually overdo the ports anyway, just to have an ample amount. Just nice like 7-inch ports or something ridiculous for a nice sub. Actually, this air velocity thing is kind of interesting because you can kind of see exactly where it's tuned, and then the way that it kind of tapers off, that's the way that it reinforces the the frequency of the bass driver. Like if you compare like the free air to the ported enclosure, and you kind of wonder how it increases the bass. That's kind of how the transient works there. It's actually kind of neat. But we'll go back to our transfer function magnitude. So we'll go to our vent. So if you do a smaller vent, it also has to be, or it can be a lot shorter. Let's do something better. Let's do a 3-inch. That's usually a nice solid, well, for a low power application, this should be pretty good. 3.44 inches with end correction. The end correction, that's like a rounded edges on the end of your port. Something like that, where it's kind of breaks the edge. Some of them break the edge more than others, but generally how that works. The other advantage to making the port diameter larger is that your accuracy on the length of the port, you don't have to be as accurate because the swing on the tuning frequency won't be as big. If you have a 7-inch long port and you're off by 1/4 of an inch, it might move your frequency a fraction of a single hertz. Whereas if it's like really small, like 2 inches, and you're off by 1/4 of an inch, that could be the difference between like 30 hertz tuning and like 70 hertz tuning. And at a certain point, it just gets kind of ridiculous. So make sure your ports are at least of a decent size. A lot of bookshelves, 1.5 inches, even 1 inch, 3/4 of an inch can be used quite well. But on floor speakers, when much larger enclosures with bigger drivers, bigger bass drivers, that's kind of an unreasonable size. So 3 inches is 2.5, 3 inches are usually a nice safe bet. Also, if you don't want to buy the official port tubing, you can just get PVC pipe and use that. Or you do the thing with the hole saw and stack up cuts with stacked blades, which I'll probably show in the construction video because I do kind of find the technique kind of fascinating, and I used it on a pair of speakers and it turned out really good. So it's generally a good idea to get a figure on what your port displacement is, and I think the easy way to do that is to use a cylinder calculator, which if you just go to Google and search cylinder calculator, it's kind of got one. So we need the radius, which is half the diameter, so 3 inches, so 1.5 inches. Okay, where did it go? 1.5, and it wants a 3.44. The other part to include is that you use your port actually goes to the edge of the enclosure, not just internally. So you actually have to subtract a bit. So if we take 3.44 and we subtract the thickness of the wood, 0.75, we're left with 2.69. 2.69. So we got 19.1 cubic inches. 19.1 IN superscript 3 to FT 3 0.011. So not exactly a lot. So if we just do our calculation here, just say it's 0.9 or 2.9, that should be pretty good. So then we got our kind of our tuning frequency. We know what our vent's going to be, And most importantly, we have our cut list. So in the next video, we can take our cut list, cut it out, and start assembling our box. Or do a video on how to assemble a crossover, one or the other. We'll see which comes out first. Till next time, have a good day.